Okay, let's try to do question 1D. So let's read the question. So two coaxial coils are wound around the same cylindrical core. Okay, so if you see the words two coils, okay, so we know that this is a subtopic on mutual inductance. Okay, mutual inductance, okay, sentiasa melibatkan dua coil lah. Okay, so let's say lah kita bercakap the coil yang pertama tu kita panggil dia sebagai primary coil. And then coil yang kedua kita panggil dia sebagai secondary coil. Okay. Okay, so essentially mutual inductance ni we have two coil lah kan. Two coil that are close together. Okay. Okay, it could be like this. Okay, ataupun it could be like this It could be like this question, contoh untuk this question, same cylindrical core. So this is a cylindrical core, okay. And then we have two coils wound together. So we have coil number 1 and then we have coil number 2 lah. So this is also a process of mutual inductance lah. Basically dia kena ada dua coils, okay. Tak kisahlah mereka duduk bersebelahan ataupun mereka dililitkan bersama, okay. Alright. So macam mana primary coil dengan secondary coil ni mendapatkan EMF induced dia, okay. So masing-masing akan dapat EMF induced lah, okay. So this is EMF induced, dia akan dapat, ini pun akan dapat juga. So the question is how, okay. Primary coil akan dapat induced EMF disebabkan oleh perubahan current dekat kawan sebelah dia, iaitu secondary coil lah, iaitu kita bercakap dia sebagai I2, okay. Manakala secondary coil ni akan dapat induced EMF daripada perubahan current dalam primary coil, iaitu I yang pertama lah. Jadi kalau kita untuk tulis equation dia, it would be EMF induced equals to negative ni indicates sensor lah. It's a concept, you just write down in the calculation lah, okay. So M indicates constant for mutual inductance, and then inilah kadar perubahan current di secondary coil, and then kita akan tulis sebagai rate of change of current I2 lah over dt, okay. Right. Okay, and then how about secondary coil? It will be negative M also, but the current akan jadi di1 sebab perubahan current pada primary coil, okay. Primary coil ni ada I1 lah. Ni ada I1, kat sini ada I2 okay. And then over dt, okay. So that is the key notes of mutual inductance. Mereka mendapatkan EMF induced disebabkan oleh perubahan current pada kawan sebelah mereka lah. Okay, and then what is another formula that you could use for mutual inductance adalah, okay, this one you just remember the formula is called as MINO, okay. MINO, this one also got MINO, okay. Right, okay, untuk MINO, okay, semua quantity belongs to them kecuali current saja, current kawan sebelah punya. Contohnya macam ni primary coil kita denote sebagai number of turn 1, magnetic flux 1, okay. M ni mutual inductance lah, kita tak denote 1 ataupun 2 sebab dua-dua nilai M dia sama, okay. And then the I would be I2 sebab kan kenapa I2? Sebab perubahan current pada kawan sebelah ni, okay. Sama juga macam this one. Disebabkan ini secondary coil, jadi number of turns 2, magnetic flux 2, tapi current I1, okay. So these are the formulas that you have to use for mutual inductance, okay. And it will not be given to you in the exam. You have to memorize these two formula, okay. Formula yang hanya diberikan kepada kamu dalam exam dalam subtopik mutual inductance adalah ini sahaja, okay. So you need to know lah this formula kan, but it's okay if you don't remember. Sebab dalam self-inductance and mutual inductance lebih kurang sama dia punya formula, okay. You just substitute this one as M lah. M. Kalau macam self-inductance, dia hanya melibatkan diri dia sahaja. Jadi kita tak payah letak di1 ke apa kan. Sebab memang dia ubah, dia yang dapat, okay. But for mutual inductance, we have two kan. We have two coil. Jadi current tu akan jadi, ia akan denote lah sebagai 1 ataupun 2, okay. So you just change the formula lah kat sini. You jadi M. Sama juga this one. They have Lino, but we can change it as Mino lah, okay. So ada guidance lah kat sini untuk tahu formula for mutual inductance, okay. So let's try to answer the question, okay. Dia cakap the primary coil has 350 turns and the secondary has 200 turns lah. So kita pun tulislah So N1, So N1 is 350, N2 adalah 200, okay? And then dia cakap when the current in the primary coil is 6.5A, jadi I1 adalah 6.5A. The average flux through each turn of the secondary coil is 0.018 Weber. Jadi ini adalah magnetic flux dekat secondary coil, iaitu magnetic flux 2 lah, kita label dia 0.018 Weber, okay? So calculate the mutual inductance. So it wants the M lah, okay? So tengok apa yang kita ada kat sini kan? We have I1. So I think we can use this one, isn't it? I1. We have N2, magnetic flux 2. We want to find the M. So I think we can use this one, okay? So Mino, okay. So M kita nak cari. So I1, this one will be I1, 2 lah. So I1 is 6.5, N2 is 200. And then magnetic flux 2 is 0.018 Weber. So I think you will get your M to be 0.55 Henry lah, okay. So unit untuk induction, tak kisahlah self or mutual inductance, will be H, Henry. Okay, so let's continue for number 2, okay. So let's read the question. So dia cakap average flux through each turn of the primary coil, okay. Dia suruh cari kan, dia calculate. Dia nak magnetic flux primary coil 1, jadi magnetic flux 1 lah. So it wants magnetic flux 1 now, okay. Berapa kat sini? Okay. When the current in the secondary coil is 1.5A lah. Jadi kita tahu kat sini current dia adalah 1.5A. Okay. So I think kita ada current I2. So I think we can use this one kan. Mino but for primary coil punya. Okay. Because we already have M. I2 dah ada. N1 dah ada. And we want to find the magnetic flux 1. Okay. So this one you just put Mino. And then M is 0.55, I2 is 1.5, and then this one will be 200, and then magnetic flux 1. Okay, you press the calculator and I think you get your magnetic flux 1 to be 2.36 times 10 to the power of -3 Weber. Okay, thank you.